Hey there folks, this is our second video, so hopefully it'll be just as productive as the first. So here we go. Remember, whenever we're going to be solving equations, which is the purpose of this video today, we are undoing what the original equation has done. So in this case, there's lots of square roots, and we always have to remember that the opposite of taking the square root of something is squaring it. So let's begin, shall we? In the first equation here, we have the square root of x equals 9. Well, we have to undo that square root to get the variable out from underneath it. So what we're going to do is we're going to square both sides. And in doing so, the radical goes away, and we get 9 squared, which is 81. Okay. That's the end of the first one. These can be really, really simple. Okay? Now, for the second equation, we have the square root of x plus 1 outside of the radical equals 6. That's pretty important to notice that it's outside the radical, because we have to get the radical by itself before we do anything. It's very similar to absolute value. It has to be by itself. So I'm going to subtract 1 from both sides. So that leaves us the square root of x equals 5. And now it's time for me to square both sides because the square root is by itself. So squared, squared, and I get x equals 25. Not too bad, I hope. Over here, number 3, okay, I have the square root of x plus 1 equals 6. Well, nothing's outside the radical, so I can just go ahead and square both sides. So I get x plus 1 equals 36. So now we're going to subtract 1 from both sides to get x by itself. And I get x equals 35. Now we solved that one a little bit differently than we did number 2. And the reason is because in number 2, the 1 was outside the square root. It was outside the radical. In number 3, it was inside. So I had to deal with them differently. Okay, if it's outside, you must get rid of it first before you square. Okay, so that's what we're looking for. Number 4 is a perfect example of this. We have to get rid of what's going on outside before we can do anything. And just like a regular equation, you have to undo adding and subtracting first. I'm going to subtract 4 from both sides. You get 2 radical x plus 1 equals 20. Now I'm going to divide both sides by 2. Whoops. Well, nobody's perfect. So, now I can cancel the 2. 20 divided by 2 is 10. And I'm left with the square root of x plus 1. Looks familiar, doesn't it? So, square both sides. I get x plus 1 equals 100. And when I subtract 1 from both sides, I get x equals 99. Okay? So everything is step by step. Get rid of adding and subtracting first. Get rid of multiplying. Now that it's by itself, then I square. And then I proceed to solve. Number 5 is a little bit different because it has 2 radicals. So what I'm going to do is, since there's nothing outside of either radical, I'm just going to square both sides. When I do that, the radicals just go away. So now I like to keep my x's positive. So there's many ways you can approach this problem. So I'm going to subtract x from both sides first. That gives me 2 equals, let's see, 3x minus 1x is 2x, minus 8. So I moved the x's to the right. The regular numbers have to go to the left. So plus 8. 2 plus 8 is 10. That equals 2x. So divide by 2. And x equals 5. Now I can easily check this. 5 plus 2 is 7. 3 times 5 is 15, minus 8 is 7, and I can take the square root of 7. So that's good. Number 6. There's nothing outside the square root, so I'm ready to square both sides. Now in this question, I'm left with x squared and regular x in the question. When this happens, remember you have to get everything on one side. So I'm going to subtract 5x from both sides. That leaves me with negative 6 equals x squared minus 5x. Then I'm going to add 6. So it gives me 0 equals x squared minus 5x plus 6. So now I'm going to factor this. Okay, and we're going to be reviewing factoring in class. In case some folks have some troubles with this, I need two numbers that multiply together to give me positive 6, but add together to give me negative 5. Two numbers that suit that are negative 2 and negative 3. And the zero product property will let me set each of these equal to 0 and solve. Add 2 to both sides, so I get x equals 2. Add 3 to both sides, I get x equals 3. And if we were to plug that in, 5 times 2 is 10, minus 6 is 4. The square root of 4 is 2. So that works. Use 3. 5 times 3 is 15, minus 6 is 9, and the square root of 9 is 3. So that's good. We're ready to move on. Number 7. Okay, this one's a little bit different. There's more than one thing over here. So when we square this, this might be a little bit of a challenge for us, okay? So, over here, this gives me just, x plus 3, because the radical goes away. But x plus 1 squared means, okay, remember that means x plus 1 times x plus 1, so we have to FOIL that out. So I get x times x is x squared, x times 1 is 1x, 1 times x is 1x, and 1 times 1 is 1. Simplify, x plus 3 equals x squared, 1 plus 1 is 2, and now, just as in number 6, I'm ready to get everything on one side because I have x squareds and regular x's in the same problem. So, minus x from both sides, get 3 equals x squared plus 1x plus 1. And then I'm going to subtract 3. So minus 3 from both sides. You get 0 equals x squared plus 1x minus 2. For me to proceed now, I need two numbers that multiply together to give me negative 2, but add together to give me negative 1. Okay? In that case, I can use, negative 2 to multiply, add to 1. Well, I could use positive 2 and negative 1. That adds together to give me positive 1 and multiplies to give me negative 2. So set each of these equal to 0 and solve. So subtract 2 from both sides, x equals negative 2. Add 1 to both sides, x equals 1. Okay. Now, we need to double check this, okay? So, negative 2. I'm just checking this now. Negative 2 plus 3. That's positive 1. Negative 2 plus 3 is 1. Negative 2 plus 1 is negative 1. Uh-oh. I know that the square root of 1 is not negative 1. So negative 2 is not an answer. So I can just cross that out. But I'm going to try 1 just in case. 1 plus 3 is 4. 1 plus 1 is 2. And the square root of 4 is 2. So that's good. That's correct. Okay? We'll go ahead and talk about this in class. We call that an extraneous solution. But for now, we are done. Enjoy your afternoon.